Okay, so let's start. So for question 3, this is about a cylinder. The weight is 100 Newton. And then find the minimum force required to raise it up the step. So 20 cm, 50 cm. The weight is 100 Newton. And when you want to raise it up the step, so you need to apply a force on the cylinder. You want to find a minimum force. So by looking at the formula of the moment, so you want the R to be largest. So the largest R that can be should be the diameter. But you need to decide which point you should take the moment, because you know when you raise it up, the cylinder will rotate about this point. So the largest distance from this point is the diameter of the cylinder. So that means you should apply the force at this point. And the force should be perpendicular to this distance. And then if you draw the free body diagram, when you raise it up, the ball, so the cylinder is not touching the ground, so there's no normal relation between the ground and the cylinder. But there is also a normal relation and also a friction at this point. But if you take the moment at this point, you don't need to consider the moment of these two forces, because these two forces passes through this point. So therefore, you just need to use the F times the diameter is 100. Then that equal to the weight multiplied by the perpendicular distance here. And of course, you need to find this one. So this one, you find it actually, this is 50. And then the height is 30. Then this will be 40. So this is 40 by just using Pythagoras theorem. Okay, then you get that you get the answer that it should be A, 40 Newton. Any question here? I just copy it down to the WhatsApp group. Then let's move on. I'll just try to have a look at one more question, and then we move on to talk about. So let's say this one. It seems quite complicated, yeah. May you draw the free body diagram of the cylinder and send it to me. Now you take the moment at this point, and then n1 times the length that is n1 times the length that is 4L. That will be equal to the weight times the perpendicular distance here. So the total length of the rod is 5L, 1 to 4, and then 1 plus 4 is 5. So the distance here is 2.5 or 5/2L. But you take the perpendicular distance, so you multiply by cosine theta. And then you solve the NL. So N1, you solve the N1. So for N1, you get at 5/8 mg cosine theta. And you substitute in this formula. So finally, you get 5/8 mg sine theta times cosine theta equal N2. You can't see this choice because you need to make use of one identity. That is sine 2 theta. I think I have taught you before. Sine 2 theta equal 2 sine theta times cosine theta. So after you use it, then you find that the answer should be B for boy. That's it for this one. Okay, so I'll give you 1 minute to have a look at it, and then we move on to one more question. M1x1 plus M2x2 divided by M1 plus M2. So x1 and x2 are the x coordinates of the mass. And then you can then use then you may ask how you set the coordinate system. It totally depends on you. It's fine if you set it in any origin, or yeah, it doesn't matter at all. Then let's move on. Here give you two examples. So the first one is L-shaped object. So you may consider that the L shape is has consists of three squares, and then you set the coordinate system as what I have done, y-axis and x-axis. Okay. Then you just cut it into three squares, and then the center of the square are these 3 points. So you see 1 times 0.5 this one, plus 1 times 0.5 this one, plus 1 point times 1.5 this one. So therefore you get the center mass of the x to be 546. Be also aware that's why I put 1 here. 1 is their mass. Now if this is a plate, that means a sheet or lamina, then the mass of this square is proportional to the area. Because these 3 squares area are the same, so I just put 1 here, because their mass has a ratio 1 to 1 to 1. Okay, but if the mass is not equal, and then you can't do it. Now you may also consider the L shape to be like this one, a rectangle with a square, is it? But the mass has the ratio 2 to 1. Okay, so you consider the mass of the rectangle to be 2 and the mass of the square to be 1. And then this is the center of the rectangle, this is the center of the square. So the center will have the coordinate system, that's 0.5, 1, and this is 1.5 and 0.5. So let's try to find the x coordinate of the center mass. So mass 1 times is x coordinate plus mass 2 times is x coordinate divided by the total mass. Then obviously you will get the same answer. That is 5/6. Okay. For the y coordinate of the center mass is quite similar. So just 2 times 1 plus 1 times 0.5 divided by 2 plus 1. You get the same answer also. Okay. But there's another easier method for you to do it. So you may also consider L shape as a big square, subtract a small square. If you subtract this small square, then you need to consider this the mass of this small square to be negative. So that means you're cutting this small square from the large square. Okay. Then the area has a ratio that is 4 to 1, but you put a negative here, negative 1 here. You still get the same answer. Okay. So I'll give you another example before you do some exercise. So have a look at this one. Any question here? Any question? If no question, then I would like you to do one exercise about the center of mass. Now, although this is 3D, but I think you can do it like XYZ coordinate. So question 16. I think 2 or 3 minutes should be in. Now, then the mass of the big cube is 8, and then the x coordinate is a. The mass of the small cube is -1. The x coordinate is 1.5 a divided by the total mass. So therefore, you get therefore in the denominator you will get a factor of 7. So that's why actually when I look at this question, I will not choose D, because I know in the denominator it should be 8 plus -1. It should be a factor of 7. Okay, but there's no this choice. Yeah, because it's not asking you to find the x coordinate. It's asking you to find the distance from the center to from point A to the center of mass. So that means you need to do the Pythagoras theorem. Center mass of x plus center mass square plus center mass of y square plus center mass z square. Then you get the square root 3. Just like for a cube, then you know the vertex, the opposite vertex has a length in square root 3. Okay, so therefore the answer is A for apple. Do you get correct? No? Yes, no? Do you still have any question on it? Any question on it? No? Then let's move on. I think there's no another question asking about the center mass directly. But I think as I remember there's one more. But I think I can't find it. Yeah, I can't find it. So how about question 15? So although the question is not asking about a center mass, but it's related to center mass. So this is a sphere. Remember, this is a sphere. So I would like you to find the center mass of this sphere relative to this point. The small sphere of radius r/4 is cut from the large sphere of radius r. as shown here. So may you show me some of the steps and then send it to me by WhatsApp? To find a center of mass, and then the like you know the ratio of the radius is 4:1. So the volume will be 4 cube to 1 cube. So that is 46, sorry, 64 to 1. The volume, this is the volume ratio. So I take the x-axis to be this one. So 46 times 0 plus -1 times r/4, is it? R/4 ma, yeah. Divide by 64 minus 1. Okay. Then you get that the center of mass will be something like this. So 64 times 3, sorry, 63 times 4, and then that's the answer. Okay. I need to leave home soon. So maybe continue on coming Monday. Yeah, coming Monday. Then see you on Monday. Okay. Bye bye.